Imagine a world beneath the world you know, a hidden layer of reality where particles can be in two places at once, where information travels faster than light, and where observation itself changes everything. This is not science fiction. This is quantum physics. Today, we'll journey into the deepest fabric of our universe, a place stranger than dreams, but as real as the device you're watching this on. Welcome to the quantum realm. Quantum physics is the science of the incredibly small. It describes the rules that govern particles smaller than atoms, like electrons, photons, and quarks. But here's the twist. These tiny particles don't behave like anything in our everyday experience. First, there's superposition. A quantum particle can exist in multiple states at once, like a coin spinning in the air, being both heads and tails simultaneously. Then, there's entanglement. When two particles become linked so deeply that the state of one instantly affects the other, no matter how far apart they are. Einstein called it spooky action at a distance. And there's quantum tunneling, where particles pass through barriers as if they weren't even there. It's like a tennis ball going straight through a wall, just because. At its heart, quantum physics tells us that nature isn't deterministic. It's probabilistic. Reality doesn't exist in a fixed state until we look at it. One of the first hints of quantum weirdness came in 1801 when Thomas Young conducted the double-slit experiment. He shone light through two narrow slits, and instead of two beams, he saw an interference pattern, like ripples in a pond. Light, it turned out, behaves like a wave. But over a century later, physicists found that when you fire single particles of light, photons, through the slits, you still get a wave pattern, unless you try to observe which slit the particle goes through. Then, it behaves like a particle. Somehow, observation changes reality. Enter Max Planck, who introduced the idea that energy is quantized, coming in tiny packets or quanta. Then, Einstein showed that light itself is made of particles called photons. In the 1920s, the field exploded. Niels Bohr, Werner Heisenberg, and Erwin Schrödinger built the foundations. Bohr proposed quantum jumps, Heisenberg introduced the uncertainty principle, and Schrödinger imagined a cat both alive and dead. A thought experiment to show how absurd quantum mechanics seems when scaled up. But as strange as it sounds, every experiment has confirmed it. This is how reality works. You may think the quantum world is far removed from your daily life, but it's all around you. Your phone? Its processor depends on transistors, which only exist because of quantum mechanics. Lasers, based on quantum principles. MRI scanners. They use quantum spin to see inside your body. Even GPS satellites need quantum physics to account for time differences caused by gravity and motion. And now, we're stepping into the next frontier quantum computing. Unlike traditional bits that are either 0 or 1, quantum bits, or qubits, can be both at once thanks to superposition. This could allow quantum computers to solve problems that would take classical computers millions of years. Then there's quantum encryption, which could make hacking virtually impossible. Or quantum sensors, which might detect diseases at the molecular level. Far from being just theoretical, quantum physics is powering the technology of tomorrow. Despite a century of breakthroughs, quantum physics is still full of mysteries. What does it really mean for a particle to be in multiple places at once? Is the universe constantly branching into parallel realities every time a measurement is made? This is the many worlds interpretation, one of many competing theories. Quantum mechanics and Einstein's theory of gravity don't yet fit together. Physicists are searching for a theory of everything, a single framework that unites the quantum and cosmic. String theory, loop quantum gravity, and other ideas are still being tested. And then, there's the biggest question of all. Does consciousness play a role in shaping reality? Is the observer fundamental to the universe? These aren't just scientific puzzles. They touch on philosophy, even spirituality. What is reality? Is the universe deterministic, or is chance woven into its very fabric? The quantum realm reminds us that the universe is far more mysterious and beautiful than we imagined. Quantum physics reveals a hidden world, A place where particles dance in probabilities, where reality flickers between possibility and presence. It challenges our senses, defies our logic, and invites us to see the universe with new eyes. And yet, from these strange rules, we've built the modern world. We've peered deeper into nature and glimpsed a universe rich in wonder. The quantum world is not just beneath us, it is within us. And as we continue to explore its mysteries, we come ever closer to understanding not only the universe, but ourselves. If this journey into the quantum world sparked your curiosity, don't let it end here. Dive deeper. Read a book, visit a science museum, or take a free online course. Share this documentary and keep the questions alive. And if you want to explore more stories that blend wonder, science, and discovery, subscribe, like, and join us for our next adventure. The universe is vast, and we've only just begun to understand it.